Welcome everybody. Thanks for coming to our session, which is on using open source natural language tools with Salesforce, or how I taught my computer to read really, really fast and make money from it. Appreciate your time here today. Just to hit this slide that we're all familiar with, Salesforce is a publicly traded company, and as such you should make your purchasing decisions based on what is present in the product today. Not on things that you may see that are in the future. We will be covering some things today that are in the future, and so as a result, you should make your decisions on purchasing with that in mind. So first off, who are we? We are from HaloSight. HaloSight is an augmented intelligence company that allows people to do a lot more with the data that's trapped inside both Service Cloud and help desk data and Community Cloud in things like product support forums. And we do a lot of natural language processing, and so we're excited to share some of the things we've learned along the way with you. I'm Kurt Williams. I'm the Chief Technology Officer. We also have presenting with us today Brian Wise, who is our Chief Data Officer. And behind me here I have David Norton, who is our Principal Data Scientist, and we'll all be taking turns sharing some insights with you today. So first off, I bet we've all had the same experience. If you've ever gone camping or up into the mountains where it's really clear and you look up into the night sky and you see all those stars, it's vast, it's really big, and I feel about this small sometimes, but it's still great to see this wonderful experience right in front of me with all of that out there. And as a data guy, I can't help but look at all that and think, that's kind of like our data. We just have so much of it, and I have to do something with it. And this is not uncommon to the human experience. We've been doing this for thousands of years, and we've all looked up into the night sky and thought, what's my place in the universe? How do I make meaning of all of that? And how do I maybe make it useful? And we've been doing that, as I said, for thousands of years. And so as you look up, you can kind of make out some shapes and pictures. And the ancients did this and came up with things like constellations. I'm not much of an astronomer, but I know some of the famous ones like Ursa Minor. And when I look up, I see things like the flux capacitor and Thanos throwing a frisbee to the other astro that's up there, maybe Optimus Prime. But the point is, I look up and I can see patterns in that and make it useful. And if you know the constellations, once you have that, you can do great things like navigate, like know what hemisphere you're in, that sort of thing. It makes it useful and it gives it meaning. But it's very easy to look up into that night sky, and after you've created that meaning and those patterns, to think, well, I've got a handle on all of it. I've got the whole night sky. It's at my command. But the truth is, it's only using part of what's up there, just like the constellations today. There's a lot of stars that aren't covered. In fact, there's part of the night sky you don't make use of even very much at all. So if you've ever seen who here's seen the Hubble Deep Field photograph? There's probably a few astronomy nerds like me, but they took the Hubble Space Telescope, aimed it at a part of the night sky that's about the size of if you took a straw and looked up. If you can see, there's a little square up there. They took a picture of dark sky, and in that dark sky was this image, which those points of light aren't actually other stars, they're other galaxies. So that was what was just lurking in that dark spot on the sky. So it would have been really easy to say, hey, we got everything with the constellations, but we really didn't. We missed billions of other stars that are sitting there. Now, our data can be the same way. There's data that we're used to using, and we are tempted to think it's the whole universe, and then there's all this other stuff that's out there for us to use, and think about things like all of the case notes that are in Service Cloud, or all of the forum postings that are in Community Cloud. Those kinds of things, they're not exactly data, right? So we don't use them as much, but it comprises a huge amount of stuff that's out there. So to give kind of a bit of perspective, this is a NASA video of that section of night sky relative to the moon and the horizon, and you can kind of see just how much is out there. It's that spot that they took a picture of is really, really small. And you can kind of see the horizon on the bottom. Same thing with our data. There's a lot out there. We don't always use it. So what is out there? So there's the structured data that we're used to. It's stuff that fits great in database tables, KPIs and metrics, and for the Salesforce people that are putting things in Salesforce, there's numbers and pick lists and checkboxes. It's all of that stuff that fits in a spreadsheet really well. It's the structured data. It accounts for about 20% of the data that we have available. But there's this other 80%, the things that I mentioned, like history notes and community feeds and chatter posts. The list goes on. There's social media, anything you could fit in a content management system, all of that stuff, and it comprises about 80% of the data that we have. 80%, when you think about how fast and exponential the data growth in the world is, it's amazing of how much stuff is growing in this area. But it doesn't get used that much. We don't use it as often as we could, and that gives me a big question of why? Why don't we use that stuff more? Why doesn't it get used? And there's a really simple answer for why it doesn't get used. And that is because it's really, really hard. The natural language processing stuff that has to go in there to read human language is frightfully difficult. Here's 2 quick examples of just small things. So one is, last night I shot an elephant in my pajamas. How did that elephant get in my pajamas? I will never know. So just being able to decipher that sentence requires context that the reader may not have and a computer certainly won't have. It makes getting the right interpretation very, very difficult. But then there's also the nuance of meaning, of what things mean, and we as humans can't always agree on what stuff means. Here's a simple mathematical example. Math is math, right? It should always mean the same thing. So quick question, 8 divided by 2 times the quantity of 2 plus 2. Give you a second to process that, but you don't have to raise your hand if you don't want to, but who here looks at that and thinks that the answer to that is 16? A few? Okay. Who here looks at that and thinks that the answer is 1? A bunch more. Now, it turns out they're both right. If you ask a math professor, and on social media they have, if you want to go research into that, which one's the correct answer? Is it 1 or is it 16? If you punch it in a TI calculator, you get 1. If you punch it into an HP, you get 16. They're both actually correct. It's an ambiguous mathematical expression, and depending on how you were trained in school, if you were trained on kind of a European school of thought, you'll get 16. If you were trained in America, you might get 1. If you're a Java programmer like me, you'll get 1. They're both right. It's ambiguous, and language is full of that, and that's just in math. Now imagine sentences, so it's really, really hard. But there's another big reason why we don't use this data as much, and it's not just because of the semantics of it. It's because there's just too much. So imagine that you're a product manager who's trying to use textual data in case history to find out where product friction is, or you're a success manager who's trying to coach an agent on what they should work on, or you're an executive just trying to find out what the next best move for your company is using this data. There's a massive amount of that. So if this one little case here, this one case, if I read it, it takes about 10 seconds, and with all the data out there, we've got one customer that sent us data about a year's worth, and it's 1.8 million cases. If all I did was take 10 seconds to read each one of those, it would take me 2.5 years of work to read all of them. I just can't do it. It's just too much data. And when you compound that with the number of emails and comments and notes and chat transcripts, there's potentially billions of facts of varying levels of value that I have to contend with. It's just too much. So you've really got the vagaries of human language coupled with the difficulties of scale when you face this problem. So that makes it really tough. So we kind of tend to go back to the data that just is easily insertable into a database table. So that's where we're at. Now, fortunately, we can make things much, much easier, and that's what this session is about today. And we're going to talk about 3 different options that are available to you to make things much easier. So the first thing is natural language processing that is available in Salesforce today. Then there's also a wealth of open source NLP libraries that you can draw from. If you're a programmer, you can go and pull those libraries down and use them and make a big difference in how you process natural language. And then we also want to look at what a fully scaled out solution looks like, and that's what HaloSite does. We have a full distributed NLP pipeline that we make available in the Salesforce ecosystem for a variety of workloads and tasks. And what does that look like if I'm not a do-it-yourselfer? And so we'll go into that as well. So we'll cover all 3 of those. So to start with, I'm going to turn the time over to Brian Weiss, who's going to tell us a little bit about what's available today natively in Salesforce.
Thanks, Kurt. Not only am I going to go over what's available in Salesforce, but I'm also going to take a quick look at just the demo that we're going to be using throughout the session today. We'll do kind of 3 little demos. So let me start not with the code, but with just a case inside of Salesforce. So I'm pretending I am KPI service, and I own a software company that sells analytics tools. And I've got a customer here, Jane Ryder, who works for Supercycles, and she's logged a case through our portal that says, I'm unable to register KPI Explorer. I can't register my copy of KPI Explorer because I can't log on to KPI Web. I keep getting an invalid username password error. Reset password link is not walkring. The walkring there, that was actually just me mistyping as I was making my demo. But it's actually a really important problem that you have to deal with when you do NLP. We'll see that pop up in some of David's code and how we deal with that.
People don't type perfectly?
No, people don't type.
Wow.
So this is our case here. And if you're using Service Cloud Einstein, you might have turned on Einstein case classification. And what that's going to do is take a look at that initial case that's come in and compare it to all your other cases and try and predict some values for you. Maybe it's recommending that you escalate the case. Maybe it's recommending you set a certain priority. That's what Einstein case classification does for you. Anyway, this particular case, Tim Service here, he worked the case. And if I look at his final disposition notes here, it says no real problem, stupid user couldn't remember her email address. So from Tim's perspective, he closed the case, it was done, and there was nothing wrong with our product, right? Everything's good? But if we go look at the case notes here, and we open up the chatter feed back and forth here, there's a lot of discussion going back and forth. And if we look at this last comment by Jane, the customer, really? You can't change this for me? This product is way too hard to get set up. Can't even open KPI Explorer because I can't log into KPI Web, which I don't even use. I should have gone with Acme Inc.'s BI tool. It's much easier to use. So there's some really great insight. If you're a product manager for KPI service or KPI analytics, there's some good information about the usability of your product, about your competitor's product that was just locked away in these case notes. And so we're going to kind of follow this today and see what happens as we do that. Just as a quick summary here, on the Service Cloud Einstein built in, you've got case classification. If you want to use Einstein language, you can do case sentiment as well by making call out to the APIs there, or you can train some more advanced intent classification models. One of the problems that we've run into is that, one, the conversation continues long after you open that case. And all of that discussion going back and forth, that's where the real heart of what the customer thinks about your product is. And so our goal is to make all of that accessible, look at all of the information, unlock the data that's in that unstructured data, and find out what's wrong with the products. What are they complaining about? What is the sentiment about a specific product? And then how do we put that into a scalable NLP process? And to get that started, David's going to introduce us to some of the tools that we use.
Right, so I'm going to step through an example natural language processing pipeline using NLTK. That is a commonly available open source solution. But before I do that, I want to talk a little bit about what we mean by an NLP pipeline exactly. So we have our unstructured data, and then we have the NLP pipeline. And the job of that pipeline is to add structure to the unstructured data. At the end of the pipeline aren't the insights we're looking for, but we have the building blocks so we can find those insights. A trained data analyst should be able to use that to find the insights we want, and there's additional tools that can be crafted that we'll see that can make use of it and get what we really want. The pipeline is all about annotating the data. So if we look at this example comment we've been looking at, annotations might include things like the parts of speech, the instance of products or other entities, and the sentiment. There's many other things we could glean from this. But as you can see, those annotations by themselves aren't necessarily very helpful, but they're going to be helpful. So I want to talk about this pipeline and how we do this, and this is where the open source solutions come into play. Let's talk a little bit about the different types of annotations that can exist in a pipeline. First, there's rule-based NLP. This is the manual approach. This is where humans come up with rules to annotate. So rules might be pattern matching, they might be queries, they might be templates. This is an example of a regular expression right there. That's a snippet of code that can be used to find dates in text. Dates is kind of a semi-structured form of natural language. There's not a huge variety of ways that dates are expressed, but there is some, and we can capture that with this this sort of expression. If it was a more complicated problem, we might need more rules, more detailed rules, but humans write these. The advantage of using rules are that when something goes wrong with the annotation, or we just want to understand why, we want to know why, people want to know why, we can look to the rule, we understand the rule because we wrote it, and we can tell you why. The downside is that a lot of work goes into these rules, right? And if the domain changes, some small change happens to our context, we may need to rewrite the rules completely. So that brings us to the other approach, which is AI, machine learning approaches. That's the hot topic. So for AI, we're teaching a machine how to write internal rules. The downside to this is those internal rules may not be something that we understand. But the advantage is that the machine can learn things that may be too difficult to write rules for and be able to adapt to new situations quicker. The first thing we need to consider when building a machine learning approach is how we're going to represent language. Machines don't understand language, so we have to represent words in a way that they understand. One representation is called label encoding, where we take every word and we assign an arbitrary ID to that word. The problem here is that we're actually lying to the machine because numbers have implicit relationships, right? 4 and 5 are next to each other, so we're telling the machine that swim and woman are very similar in meaning, and that's not necessarily true. So we usually use one-hot encoding. With one-hot encoding, instead of a single ID, we use a vector of numbers, a sparse vector. And that vector is unique and completely unrelated to any other word's vector. That way, every word has a unique encoding, and we're not lying to the machine. Obviously, it would be much more impressive if we could give true relationships to the machine. So the most popular method now is called word vector encoding. In word vector encoding, the vector is actually a position in what's called an embedding space. The embedding space, of which there's many varieties, there'll be hundreds of dimensions, but this popular image right here shows an embedding in 3 dimensions. And a word embedding, the position of 2 words actually does indicate similarity. A cluster of words together are synonyms, essentially. In addition to that, you can encode vectors, or vectors are discovered in these embeddings that encode certain relationships. For example, there's a male-female relationship demonstrated on the left and a verb-tense relationship demonstrated on our right. And these relationships really emerge from these. These embeddings are available. Many of them are pre-trained on massive sets of English language or other languages, using Wikipedia, that sort of thing. You can learn a lot more about them with a couple of trailheads, actually, that are in this slide. I think these slides are going to be made available at some point.
Anybody having SAT flashbacks here? King is to queen, as man is to what?
Yeah, so if you loved math and grammar in school, then this stuff will give you a real kick. All right. So once we've got our representations, we got to train architecture. We have to design an architecture. I'm going to show you the outline of a common architecture used. It's a bit complex. They get more complex. But the general idea is we're tagging sequences of words. So the big house, we want to assign a tag to each of those words that's going to be helpful in our pipeline. This is an example of part-of-speech tagging. So here's what an architecture might look like. Here we're taking word embeddings, word representations at the bottom, feeding that as inputs to 2 layers of recurrent neural networks. You may have heard of a neural network. Neural network is a model used to classify things. It takes input and it classifies what it is. A recurrent neural network is a network that takes input like word representations and also takes input of the previous instance of that same model. And we can train it in sequence from left to right, and we can train another one in sequence from right to left, because different things can be learned by looking at words in different sequences. We take the output of those, concatenate them into input into another classifier. You've heard about deep learning. Deep learning is about layers. So here we've got 3 layers. Some approaches to deep learning have many more layers, much more complicated layers. But it's all about layering these networks, these classifiers, and taking their outputs, putting those inputs to the next layer. At the very end, we have an output function. And the output function turns that output vector into a value that's useful for us to annotate. So in this example with part of speech tagging, let's look at big down the middle. At the end of this output function, we have probabilities of each potential part of speech. Determiner, 20% chance. Adjective, 70% chance. Noun, 10% chance. So we pick the most likely candidate as our adjective. This is the kind of thing going on in a lot of these classifiers. So it can be difficult to build these, very difficult to build these from scratch. You don't have to build these from scratch. There's a number of open source solutions. I'm not going to read everything on this page. This is for you to take a picture of and look at. But here's 4 common open source solutions. There's more. They all have their strengths and weaknesses. What they're all going to provide are pre-trained models for many common problems, like part-of-speech tagging. So you don't even have to train a model. Or architecture, so that you can more easily train a model. Or even rule-based approaches, right? Some common rules that people like to use. So now we're going to go into demo mode. And I get nervous and can't operate a computer. Okay, so this is a Colab notebook. So this is Python code we're looking at. And we're looking at the NLTK open source solution. We're going to go through an example pipeline that you might really see underneath a lot of solutions. Einstein may even use a similar pipeline at its beginning part.
So we'll take this notebook and the slides and just put them on the session chatter page, and you can go just run these yourselves if you want to check out the code here.
Okay, so we're going to actually run through this live. So here's our first we set the text. This is the example we've been looking at all along. The first thing we want to do is we want to split up the text into sentences. So this is usually a regular expression, rule-based a rule-based approach. You might think, oh, let's just split on periods, and that's fine, maybe most of the time, but abbreviations, URIs, they have periods, so you have to be smarter about that. Things to consider. NLTK has a basic tokenizer that works very well. Here's the sentences that we obtained from that. The next step is tokenization, tokenization is where we take each word and we isolate those words into tokens. Those are the building blocks for the rest of the pipeline. This is also rule-based. The pen tree-based tokenization rule set is very popular. Every open source solution usually has that as their default tokenizer, and it's effective. So we run that through and we see tokens. These are arrays of tokens. You'll notice tokens aren't just words, they're punctuation, and they separate contractions into their separate meanings. So every pipeline is going to start with this. Now we'll look at part-of-speech tagging. This is our first machine learning approach, okay, not rule-based. They use a perceptron. This is a much simpler model than what I demonstrated earlier in the slides, but NLTK has a fairly effective perceptron model, pre-built for you to get part-of-speech tags, and this is what they look like when they pop out. We've got tuples of token and tag, and there's about 40 different part-of-speech tags. These are the pen tree bank part-of-speech tags. Next, we have another rule-based approach. This is called lemmatization. Lemmatization is finding the root of a word. Not very exciting from a business perspective at the end of the whole process, but really important for other steps in the pipeline. Sometimes you have to run a step so that the next step can be more effective. This uses another library called WordNet. It's an ontology of the English language, and they have a number of other languages. We use the part-of-speech tags that we just got from the previous step to ask WordNet to tell us the root, the most popular root given that part of speech. And that's what we do right here. And these are our new tokens. There's base words. You'll notice getting up here. This became get. You'll also notice that walkring did not become work like we would have liked it to. You may want a spell correction step in a pipeline. That would be another step in the pipeline, potentially. Or a more intelligent, maybe a model-based approach to lemmatization. Next, we'll look at named entity recognition. Entity recognition is identifying entities, specific entities. These three are common in your NLP solutions. This is organizations, people, and places. You'll also get times, dates, money, that kind of thing. These are really effective. Many open source solutions are good at identifying these three things. It's because there is a popular free data set called it's part of the Connell data set that has good training data for this particular problem. So these are effective. There are also lists called gazetteers used to augment this sort of data. So many of our open source solutions do quite well at these kinds of problems. So we'll look at how our NLTK solution does with these solutions. So now we have tuples they still have our part of speech tag, and now we have our entity. O means other or out of data set. So this is a category that the algorithm doesn't know about. Let's see how it does with KPI Explorer. We know KPI Explorer is a product. This model doesn't know anything about products, but it does know about organizations. So we're going to give it partial credit because it identified KPI, which is an organization, and then it thought the whole thing was an organization. The B means we're looking at the beginning of an entity. I means we're looking at not the beginning of an entity, the middle or the end of an entity. In order to identify products, we would have to train a model for products specifically, of which there aren't too many data sets out there for that sort of thing. So you might have to train your own model. But if you're happy with people, places, and organizations, most open source solutions are going to have a good example of that. Finally, we'll look at sentiment analysis. Sentiment analysis usually is looking at the sentence. What is the sentiment of a sentence? Is it positive, negative, neutral? NLTK has a number of options. Vader is one of them. This is a lexical and rule-based approach, but there are models, machine learning models as well. So this means there's a dictionary that data scientists have labeled, linguists have assigned a sentiment to every word. And then there's a bunch of rules on how we combine those words in a sentence together to give you a numeric output for the sentiment of that sentence. We then threshold those into three labels, positive, negative, or neutral, and there's our sentiment for the three sentences we were just looking at. Now I got a whole bunch of code here that exists solely to output what we've learned. So in our little pipeline we just ran through, we got our sentiment for three sentences, we got our tokens, we have our lemmas, our parts of speech, and entity tags. So
you could hand this to your manager, right, and tell them you just did some nice text analytics, and they could use that to make a decision, right?
We're good. No, obviously not. But a trained individual might be able to find data from this, and the right tools might be able to, and that's where Brian and Kurt are going to go for the rest of the presentation.
Okay, great. Thanks, David. Let's see, where is your, there we go. Okay, great. So, as Brian just mentioned, you've done this great pipeline in open source, but you still have some problems. For example, how do I scale that up? I've still got thousands or maybe millions of text items to process. How do I do that? How do I do it repeatedly? How do I make it accessible so that those business users can actually consume it? That table of numbers isn't going to help. How do I make that usable for that group of people so it's intuitive and simple? And then last, how do we make that whole thing simple enough that we can repeat it? Data scientists will spend 80% of their time just massaging data. We don't want to do that every single time. So how do we make that simple enough that it can happen all the time? And that's where a solution like HaloSite comes in. As I mentioned, it's an augmented intelligence platform. It's coming soon to the App Exchange, so it's simple to just turn on and go. So if you don't want to be a do-it-yourselfer with all that natural language stuff, you can grab HaloSite off of the App Exchange. Our pipeline looks like this. I'm not going to spend a lot of time in this, but the platform itself handles things like security and monitoring, Data integration, so you don't have to. So we have a connector with the Salesforce environment. We do pre-processing that I mentioned a second ago, including things like spell check to take out stuff like walkering. We do lexical and syntactic analysis, sentiment, named entity extraction, so you can find things like product and feature names. And we extract semantic facts. That's so that later, if you want to ask a question that you didn't think of at the beginning, you can. You can go and scan for questions that you didn't even know you had starting today. We put all of that information in a knowledge graph. A knowledge graph you can think of as the sum total of the information that's inside a feed, like Service Cloud or a community forum that's about a particular product. You can come back and query it later. Different than a warehouse in that it's designed so that you can ask questions in the future that you didn't think of today, whereas a warehouse is more of a cube of questions that you thought of yesterday. It makes it available to surface on things like lightning reports and in Einstein. And to show us more about that, Brian's going to give us a demo of how this information can get made much easier to access by a business user.
All right, so let's jump back into our case that we were looking at here. And let's take a look first at the graph visualization. So this is a representation of that graph database. And a little hard to read up there, but if we want to see everything with neutral sentiment, there's the neutral sentiment. Here are all the sentences that had negative sentiment down here. You can find individual products like KPI Web and then see the sentence and where that product existed. And so this is a queryable database. This is kind of a fun visualization to see what that database looks like and all the relationships in there. Another way that you might look about that is to put it in Einstein Analytics. And so what I'm looking at here is all of the blocks of text. So 11 blocks of text were analyzed in this particular case. And if I'm a product manager, I go in and look at this and say, oh, man, Acme Inc. is my competitor. What are my customers saying about Acme Inc.? Oh, shoot, they're saying it's easier to use and it's cheaper. Well, that's not a good thing. Let's take a look at my product. I'm responsible for KPI Web. They're saying things like it's really slow, can't log in, logging into. And another thing that we have here is the sentiment graph. So this sentiment graph, the red is when the contact is speaking, and the blue is when the agent's speaking. Runs from 0 to 5 on the sentiment score. And the 0 here, the customer is really upset. So let's see what the agent said right before that to make her so upset. And the agent says, I'm glad that worked. Everything looks great. I'm going to go ahead and close the case. Well, that's pretty innocuous. Why did that tick off Jane so much? And we go and look at Jane, and this is where we get that comment I read before. Really, this is way too hard to use. And we can see that raw text there. It was kind of maybe a premature close, and the agent didn't really get what was going on, and that's what got Jane so upset. So this is just one way to visualize that information. And again, this is just the visualization for that one case. So the next obvious question is, how do I roll that up across my organization here? And so I'm going to switch over to a product dashboard. And this is where we can look across all 30,000 blocks of text, 3,000 cases, and see this information. And so when we talk about entity detection, we might have a list of known products that we can feed in and help train the model, our products. So those are our known products. Or we can look at products that were discovered and just mentioned by our customers in there. So we didn't have to train that at all. It just says, hey, I think that's a product. You might be interested in looking at that. We can also combine the NLP that we're doing with just our structured data. If we want to take a look at cases coming in over a phone for whatever reason, Power BI has come up a lot in the last quarter. And so this represents a way to take all of the work that David did in the NLP, and I'm glad I don't have David's job, sum all that up and make it in a usable, put it in a useful fashion so that business executives can actually use this to make decisions on the platform. So that was the final demo. Kurt, you want to finish this up?
Yeah, great. So just in summary, you've got a universe out there full of all kinds of unused data, but it's hard to turn that into meaningful facts. But luckily, there are some great tools available, both in the Salesforce ecosystem, on the open source market, and with Salesforce App Exchange products like HaloSite that can make it a lot simpler to use this information. We like to say you take that structured data, combine it with the unstructured data together in something like what HaloSite does, and you get Halo data. So, thank you for your time today. If you want to get the slides, those are going to be available on the chatter page. Also, I wanted to mention that we are opening up our platform for a free beta during Dreamforce. If you sign up at this URL, or if you take a picture of that QR code or grab one of us, you can sign up and get free access to our service from January until June of this year. So it's a great way to find out what's in your database at no cost. So please come up and talk to us. If you do so, we have some of these Halo socks. I like to call them Halo socks. So if you want a free pair of socks, come grab us, and you can also ask questions and find out more about this beta program. We have just a few minutes left. Wanted to open it up for any questions that anybody has. If you ask a good question, there might be a pair of Halo socks in it for you. Yes?
How do you train it on a product?
So the question is, how do you train it on specific set of products? And the features also, because it's deeper than that. And maybe I'll turn that over to David. He's our expert in this area. And I'll just say that it's not an easy task.
Yeah, so it isn't easy. Your product might have a simple name like KPI Explorer. It might be a name like The Assassination of Jesse James by the Coward Robert Ford, right? That's the name of a movie. That's a product. It's also a sentence with parts of speech in it. So there's a couple things. One, that sort of a product is really impossible to identify without something like a gazetteer or a list.
We're down a laptop.
And then it's a matter of being able to intelligently match up your text with something in that list, including mistakes, typos, things like that. Then the other side of it, you can, given the context of the language, you can identify what may be a product based on what it was talking about. For example, if I said, oh, I broke my computer, right? I broke my laptop. My is suggesting that you're talking about something, a product. So that may be a product. And you can use rules to help you identify that. On top of that, because those sorts of patterns exist, you can learn that stuff with a sequence tagger, some kind of deep learning algorithm. And we use a variety of approaches to do that. We kind of combine the rules, we combine the list, and we combine the model based on deep learning that uses word embeddings that we talked about to give us the answer we're looking for there. So, and then the way it can be demonstrated to the end user, as Brian showed, he had the blue, maybe you may not have noticed, but there was the blue products and the red products. The blue products were those provided in a list. So the customer says, these are our products. The red are ones that we're predicting. We're saying, we think these are products. You could ignore those if they're not accurate enough, but they might surface new things.
Yeah, a lot of the insights can come from those inferred products that you may not know. So that's a great question. Come on, grab some socks afterwards, Whitney. I'd throw them, but I'm a terrible throw. Yeah?
We have, if we figure out these potential products, can you add them back to be trained the model? Or is this something you can see?
So is the question, can you take those insights that you find from a product and use them in subsequent models that you would use?
Yeah, I saw Power BI there. So can I push that back to say that's one of the products I'm interested in having in my model? Or is that something that you're your side of?
Yeah, I'll take that one, Kurt. So when we find insights like that on the entity side and say we detect this as an entity and we say maybe it's a competitor or something like that, we have a spot. You just go into Salesforce and you can see that entity list and you can provide feedback on that and say, I want to ignore this product going forward, or I maybe want to classify that as a competitor's product or something like that. So we've got a little feedback section.
Okay, great. Yes, why don't, right here.
Assuming I already have data available, what's the average or usual lead time to get that production?
So the question is, what's the operational lead time if you have that information or provide us stuff that we can analyze? I think if I understand that question right, there's a couple of answers to that. One, as far as our connectivity to the data, our goal is to load that data as quickly as you want to, and then process that. So typically you aren't looking for real time, but just close to or within a roundabout of real time is workable. The other side of it is the product list that you're discussing and getting a model trained for that. That takes more time you have to, if you're taking a machine learning based approach, you do have to have a way of training that model based on a product list. But provided that we have the data to do it, that can take, David? It depends on there's a lot of depends in there.
Yeah.
on how that works.
Your experience around implementing this.
Yeah, so like a custom model, so
To build out a custom model
yeah.
would take probably weeks.
Yeah, it takes several weeks to do that. You don't want to start from scratch most of the time because it can be fairly involved, and that's not our goal to do that. Our product recognizer can find lots of different products, and what works well is starting with kind of the general purpose and then using a rule based on top of that with a fuzzy search, so you can get something that just starts working almost immediately, and that's kind of where we're headed with that too.
Yeah,
We
you don't
have
have to
time
build the model to get benefit from
We have time for probably one more quick question. Right, yeah. Support for different languages other than English. So right now we are primarily focusing on English, but on our roadmap also is focusing on other languages. We've done this in the past. Multiple languages are important. Now there's some good news in that area. Language identification is very, very well developed in the field of natural language processing. So that's step one in the pipeline, is identifying language, and it's a very common problem. And then there's two options to handling that. One is where if you want it immediately, you can do machine translation from another language into English and then use whatever your English models are. It works, in my experience, it works good enough for lots of tasks, and you shouldn't rule it out. You do lose some things like idioms, for example, don't translate very well in those things, so you do lose some precision when you do that, but it can work really well for certain loads. And then if that's not good enough, you can do trained models and rules natively in those languages as well. So there are options that will work today, and then ones that take more work for tomorrow. If you have further questions, we appreciate your time. And if you have further questions, come and grab us, either about the beta or about the product or NLP in general. We're happy to help out and connect. And there's a pair of socks in it if you do. So thanks for your time.